Swayam Prabha. Digital India. Educated India.
Greetings everyone. Today I, Suhani Goyal,
and I, Divita Mathur of Sun City School,
present to you
Catapultinate, the ultimate catapult.
Today we present to you Catapultinate, a project that will alter your views of Newton's third law. Millions saw the apple fall, but Newton was the one who asked why. Firstly, to begin this presentation, let's understand some history.
Suhani, you do know that we're here for physics, right?
Of course I know that, Divita, but there's a lot of history behind physics as well. A lot of history behind Newton's laws. Sir Isaac Newton worked in many fields such as mathematics and physics. In 1666, he presented Newton's theories of gravitation. And in 1686, he presented his 3 laws of motion in the Principia Mathematica Philosophiae Naturalis. Through his contributions to these fields, Newton revolutionized science.
That was quite informative, but why don't we look at some more real-life examples now?
Okay, that makes sense. Let's start with a real-life example.
Hey, what is that for?
This is a perfect example of Newton's third law, which states that for every action, there is an equal and opposite reaction.
Over here, action and reaction refer to forces. If object A exerts a certain amount of force on object B, then object B will exert an equal amount of force on object A in the opposite direction.
The action here was me hitting Divita, and the reaction was her hitting me back.
Suhani, that's not a good example.
Maybe you're right. Let's look at some instances of the Newton's third law in our daily lives. Firstly, there's playing basketball. When we dribble a ball, the ball exerts a certain force upon the ground.
A rocket produces thrust through action and reaction. The engine produces hot exhaust gases which flow out of the back of the engine. In reaction, an equal and opposite force is applied.
All of us walk and run every day. When we walk or run, we exert a force opposite to the direction of motion on the ground. And according to Newton's third law, the ground then exerts a force on us that is equal and opposite to our force.
When a plant pushes its roots into the soil as an action, the reaction is when the soil exerts an equal and opposite force on the plant, providing anchorage and support.
Divita, wait, I just realized. Newton's third law can be applicable to technology as well.
Uh-oh, here she goes again.
Come on, Divita, it's a good example. Trust me for once.
Fine, what is it?
So basically, when I post on social media such as Instagram, Facebook, that is my action. My friend's reaction is to like my posts.
No, just no. But I suppose you're right about the technology part. Newton's third law can be applied to technology-based gym equipment. Gym equipment is mostly pulley-based, so Newton's third law of motion can also be used here during workouts.
Oh, and not to mention wheels and levers. They're all based on reaction force. This is the driving mechanism for these gadgets.
True. Now, for our experiment, we will be displaying a catapult. A catapult is a ballistic device used to launch objects at high speed. Circling back to some history, catapults were used in ancient times as military weapons.
For all the history lovers out there, do you remember the Greeks and ancient Romans? They used a crossbow-like device known as a ballista. While this is similar to a catapult usually designates a larger engine with a long throwing arm that throws rocks.
Modern mechanisms using hydraulic pressure, tension, or other force to launch gliders, aircrafts, or missiles can also be called catapults.
Divita, I'm sorry to interrupt you, but I wanted to make a joke about catapults.
Suhani, all your jokes are a long shot. Get it? A long shot.
Okay, let's just move on. The objective of our experiment is to prove that a catapult uses Newton's third law of motion when flinging an object. We used 10 ice cream sticks, 2 of which are wide and 8 of which are narrow, an eraser, which is used as the weight or the payload, and elastic bands.
Firstly, we take the 8 narrow ice cream sticks and put them together in a pile like this. Now tie one rubber band at each end tightly to put these ice cream sticks together. Now take one wide ice cream stick and put it in between the top two narrower ice cream sticks like this. Now take another wide ice cream stick and use it as a base below and tie these two wide ice cream sticks together. So, before we understand the physics behind catapults, let's first look at its parts. The pile of 8 ice cream sticks over here is the fulcrum, the rubber band at the front is the counterweight, the ice cream stick on the top is the throwing arm, and the ice cream stick at the bottom is the base.
Now that we've understood the parts of a catapult, why don't we have a demonstration? Firstly, we take the eraser, which is known as a weight or payload, as I mentioned before, and we pull the arm of the catapult downwards. Here, the elastic bands are stretched tight, which has potential energy. When this is converted to kinetic energy, the eraser then goes loose, throwing both the arm and the eraser.
Over here, the action was when we applied a downward force on the throwing arm, and as a reaction, the throwing arm applied an equal and opposite force on the object, thrusting it forward.
In larger catapults, such as a ballista or a crossbow, which were used in ancient times, we can see that they have a bigger fulcrum and a bigger throwing arm. I can assure you, if we threw an eraser from a ballista, it would go way further than from our little catapult. Lastly, the result of our experiment. We can conclude that a catapult does use Newton's third law of motion.
Thank you.